Hello community. Let's talk what to do when GPT-4 plugins fail. So, let's say we have a PDF file. And you have a lot of plugins in the plugin store from OpenAI. You have plugins called Talk to a plugin, or Chat with a plugin, or Read a plugin, or Interact with your PDF, or whatever you have. What they have in common, if you have huge PDF documents, they cut those PDF documents in particular segments, which they are called chunks. And then GPT-4 asked me, after I downloaded the first chunk of document 1, hey, do you want now to download the second chunk of document 1, and so on, and so we go. And if you have a second document, all over again. Now, in general, we have two options that happen to us with these plugins. Either those chunks of text are copied directly as an input to our LLM. Let's say GPT-4 with 32K context windows, the token length. Or, and this is the second, if we have multiple documents that are much longer than 32K token length, we have vector stores. Think about all the different interface functionalities we have. So we apply embeddings on those chunks of copied text from our PDF file, and we store those vector embeddings in a vector store. Maybe some other documents on the vector store, but a vector store is just a database where we have converted everything to vectors so we can perform the mathematical operation of a cosine similarity. Great. Both approaches can theoretically fail. Also in real life. Look at me. I experienced that my GPT-4 plugin that is called Scholar AI for archive preprints on scientific domains, I experienced that complex mathematical formula that are written in LaTex are not read by this plugin. This plugin completely neglects mathematical formulas that are a little bit more complex. This is not great. This is not great at all if you read an archive preprint here, new mathematical methods, how to call or how to calculate an attention mechanism, or how to optimize here your LLM. If you have different tensors now and you have new ways of matrix multiplication or of quantization, and all mathematical operations are not read by this plugin and are completely neglected by this plugin. And I just found out days ago, and I thought, why is GPT-4 so stupid? Why is it not recognizing? And then I found out that the input generator, my plugin, this plugin Scholar AI, completely deletes mathematical formulas, which is really great to find out. Second approach, we said, we take everything that we copy from a PDF, maybe including mathematical formulas, maybe not including mathematical formulas. It will depend on your specific plugin that you will use or that you pay or that you create. I will build my own plugin now. And as I told you, we have vector stores. Now, the format, the inner workings of these vector stores are quite complex. And maybe the format of the vector store is not optimal for your semantic content. This starts with the optimal tokenizer for your domain-specific text, for your domain-specific books. If you operate on, biochemistry, you will have a complete different specific vocabulary compared if you work in law or in legal matters. What if your tokenizer has also the ability to have out of vocabulary terms, technical terms, or terms that are not in the vocabulary, that maybe your tokenizer will simply ignore that they exist. This is a lot of fun. Second, if you say now, and this is here the query by the user, hey, summarize the following text. And you have this command, which is intended for an LLM to understand the natural language model here. But now this is diverted to a vector store. And the vector store takes now this command, summarize the following text, and it has a database full of vectors on biochemistry. But the cosine similarity with the sentence, summarize the following text, has nothing to do with biochemistry. So you get simply a mathematical failure out of the question you provide, since this input was not designed for as an input to the vector store. Now, of course, you can find solution, you can find workarounds. You can add a small large language model as an input gate now to the vector store. So if you have now an instruction for in natural language spoken for the LLM, now you have a second smaller LLM that translate this now for a vector store. But this is completely nuts, because now you pay here the commercial vector store, and you pay for each token, I suppose. Then you pay here the LLM as the gatekeeper that acts here in front of the vector store. And plus you pay for the main large language model, let's say this is GPT-4, and you pay for the transfer rates. And I mean, this is nuts. What is a nice solution? And this is why I like now here our large language model with some huge context length here in our token length. GPT-4, basic now 32K of token. This is about 22,000 words, or depending on the size here, 40 to 42 pages of text. Or if you take Claude 2 with 100K token length. These are about 70 to 72,000 words, or about 120 pages of text. This could be a small booklet that you can have here in the input prompt to Claude 2. I mean, of course, if we talk about the most intelligent and the most beautiful and the most gorgeous Microsoft solution here, remember LongNet, where they said, yes, you scale it up to theoretically 1 billion token and beyond. Yes, so that you have here, one idea was the complete internet just in one prompt. And I thought, why you need to build an LLM for prompts if there's only one prompt for the complete internet? But this is a question for another day. The positive fact here is, with this solution, no document information is missed due to the vector-based similarity search function, like the cosine similarity, that you have inside of your vector store. Because now, for example, the complete book, you just read in the complete book with 100K token length. So this is here something that is really a very nice new development. We just have to look out if they're really all the content independent, where it is positioned at start to end, if it's really read with the same attention. I want to show you this here in a practical example. So I have here chapter 2.2 on dilated attention. And this here is an image I took directly out from the archive preprint. And as you can see here in the second line, we have a very simple formula. But look now, if I string copy this from my PDF, you see that I get just part here of the formula, and here NW is completely without any mathematical operation. So it completely fails here on the simplest form of a mathematical structure. Even if you do string copy from the PDF or select all in the PDF and copy into the prompt of GPT-4. So this is not working. Yeah, to show you this again. So this is how it should be. And this is the chaos that you get if you just copy it. So I said, okay, let's ask the most intelligent people in the room. And this is GPT-4 here in my little room. And I said, hey, what to do? And GPT-4 comes up and, hey, if you're dealing with a PDF, the best solution would be to get the original LaTex file. If this is not possible, you could manually transcribe the mathematical formula into LaTeX yourself. Yeah, I sit down and I start to describe manually hundreds of mathematical formulas. And GPT-4 tells me, unfortunately, in this current environment, I do not have the capability to use external tools or services to convert PDF to LaTeX. And even I do have the capability to use external tools, I can tell you the quality is not acceptable. So GPT-4 tells me I'm limited to text extraction from PDF using Python libraries like PyPDF2 and PDFminer. And these libraries do not have the ability to convert this to LaTeX. And then I thought, wait a second, when I published, I was sitting hours and hours to write my formulas in LaTeX. So I said, can I get here the LaTeX source file? Look here. This is here from Cornell University archive. And here I have my preprint. LongNet scaling transformers to 1 billion tokens. And normally I click here in the download area on PDF. But if I click on other formats here, I get to this page here. And in this page here, I have here the PDF, yes, but I have also a source file. And if I click here on download source file, I have some source file that is downloaded. I rename this source file. I just add here .tar.gzip. This is, you just add these characters. And then I do a 7-zip and unzip, and this is what I get. And here you see a file called longnet.tech. And this is my LaTeX file. So let's see if GPT-4 can now read LaTeX files. So here we are live now in GPT-4, and as you can see, this was the last message. I do not have the capability to use external tools or services to convert PDF to LaTeX. I am limited to text extraction from PDF to using Python libraries. And then now I upload here my LaTeX file. And I say, tell me what chapter 2 is about. And this is here now the code interpreter GPT-4, where I can upload the LaTeX file. And the code interpreter comes back, says, apologies for the misunderstanding, but your file you uploaded is a text file, which is a LaTeX source file. To provide an overview of chapter 2, I need to read and interpret the content of this LaTeX source file. So let's proceed with reading the LaTeX file and identify the content. And then comes back and says, done. Chapter 2 of the LaTeX document appears to be titled Dilated Attention. Yes, this is correct. It presents the concept of dilated attention in context of improving transformer models, which are widely used in the field of natural language processing. We have dilated attention, how dilated attention works, multi-head dilated attention, computational complexity and token dependency. And then finally, point number 5, how to scale up to 1 billion tokens. And then I say, okay, show me now the mathematics of dilated attention. And it's a miracle, but Code Interpreter comes back and says, sure, here are the main mathematical concepts and formulas for dilated attention as described in chapter 2 of the LaTeX document. Look at this, computation of dilated attention. Here are my mathematical formula. This is it. Yes, absolutely. Yes, this is it. These are my formula that I need. Oh, it is so beautiful. It is so beautiful to find a solution here. Because you know what this means? It means I can upload several mathematical preprints and Code Interpreter is able to read them, to show it to me, and I can work with those summaries without having to read each and every PDF or each and every LaTeX file. Great. So you can see here, here does this query key value tensors, segment size, the offset, yes, computational complexity. Look at this beautiful formula. Isn't it gorgeous? LaTeX. So LaTeX is something that Code Interpreter is able to read, to interpret, to explain, to output. And this is amazing. Token dependencies. So it really shows me here the formula of the LaTeX file. Great. And I said, now that you can read the mathematical formula, explain how to calculate dilated attention. Step by step, for me in detail. Take your time, be precise. GPT-4 comes back, great. Dilated attention is a variation of the attention mechanism. You know this, splitting the input sequence into multiple segments and apply different attention patterns to each segment. Here's a detailed step-by-step explanation of how dilated attention is calculated. First, splitting the input sequence. The input sequence is divided into multiple segments of length W. This is achieved by selecting every odd element from the sequence, where R is the dilated rate, which controls the amount of sparsity in the attention, and W is the segment size, which represents the length of each segment. Each segment is processed independently from the other segments, allowing for some parallel computation, multi-GPU computation. And then here, calculation of query key and values. For each segment, a set of query key and value tensors are extracted. These are simply subsets of the original query key and values for the entire sequence, but now selected according to the dilated pattern. This extraction process can be represented mathematically, yippee yabba do, as follows. Here, look at those formulas. I am loving it. And then we have computing the output, computed by applying the attention softmax to the query key and values, can be represented with this formula. This computes the attention weights by taking the dot product of the query and keys, applying the softmax function to convert these into probabilities, and then computing a weighted sum of the values according to these probabilities. Second, recombining the output. The output segments are then recombined into a full sequence output. This involves scattering the output of the segments back into the original position in the sequence and concatenating them. The scattering operation can be represented, yes. And then mixture of dilated attention to capture both the long range and the short range information, the semantic information of the words. Effectively, the process can be performed with a mixture of different segment sizes and dilation rates. The final output is a weighted sum of the outputs from each attention pattern. The weights are dynamic and calculated by the denominator of the attention softmax function. These steps describe the forward pass of dilated attention in a neural network. During the backward pass for training, gradients would be calculated for the model parameters and updated to minimize the loss function. A LaTeX file, it is so beautiful. Then I go say, read the complete LaTeX file and give me a mathematical overview of the most important formula in this document. So it comes back, let me try another approach to extract here the mathematical equation. Let's see what it's doing. Let's attempt to use a simpler regular expression pattern to extract mathematical content, which is common, yes, $sign, yeah, the $sign, okay. Then we have simply a regex, find all pattern, yes, clean up, beautiful. Okay. Based on the extracted LaTeX expression, there's some kind of the key mathematical concepts and formula of the document. Now he gives me 6 main mathematical functions. First is computational complexity of the attention mechanisms that we know, the dense, the sparse, and the dilated. Formulation of queries, yes, we know our tensors. Then explain the sparse attention pattern, yes. Fixed pattern of sparse attention, load and strident pattern. Told you about this in my last video. Dilated attention, yes, here we have them in beauty, in mathematical beauty, finally. Each segment is then specified along the sequence dimension by selecting the rows with an interval. Yes, computation complexity of the latent attention is approximately of the order ND with a token dependency of approximately order of log n. And n is the sequence length, and d was the dimension of the input vectors. And the mixture of the latent attention to capture both long-range and short-range information effectively. A mixture of dilated attention is implemented with different segment sizes and dilation rates. The final output is a weighted sum of the outputs from each attention pattern. Please note that these formulas are high-level summaries of the mathematical description in the document. For the complete mathematical details, including all assumptions and derivations, please refer to the original LaTeX document. I am impressed, and I found a solution here. So GPT-4 Code Interpreter is the way to go if you want to have archive preprints, either mathematics, physics, chemistry, whatever you have, wherever you have more complex visualization that require a LaTeX formulation, a LaTeX presentation of your scientific content model. Here, the code interpreter is able to read it, to analyze it, and to a certain extent to understand this. This is great for an exercise where I set out how to explore this, and at first there was only failure. But now with LaTeX and Code Interpreter, we found a powerful duo without powerful tools to solve this particular task. This was it for this video. It was great, it was fascinating, and I found a solution. I hope you enjoyed it, and I see you in my next movie.